Hello, mathematicians. Today we're going to be learning about compound inequalities using OR. So here we have negative 6x plus 14 is less than negative 28, or 9x plus 15 is less than or equal to negative 12. And what this OR statement means is that the solution for x could either be true for this inequality or for this inequality. It's true for at least one or both of them sometimes. So here, the first thing we have to do is solve for x. So I'm going to subtract 14 on both sides of our inequality. Positive and negative 14 cancel out. So here I'm left with negative 6x is less than negative 42. And in order to isolate x, we need to divide both sides by negative 6. Those cancel out, and x is greater than 7 because negative 42 divided by negative 6 is positive 7. And the reason why we flipped our inequality is because whenever we divide or multiply by a negative number, in order for our inequality to still be true, we need to flip our inequality. So here we have x is greater than 7. So let's isolate x here by subtracting 15 first on both sides. Nine x is less than or equal to negative 27. And in order to get rid of the 9, I divide both sides by 9. That cancels out. Divide by 9. Since I'm dividing by a positive, we do not need to flip our inequality. So here we have two inequalities. We have x is greater than 7 and x is less than or equal to negative 3. And before we do anything else, let's see what that looks like on a number line. So I'm going to start my number line with negative 3 to make it easier. So negative 3, negative 2, and I could go a few more if I wanted to. So for this inequality here, where x is greater than 7, we plot an open circle because it's not equal to, it's only greater than, and we shade to the right because x is greater than. Okay. And then for our other inequality, where x is less than or equal to negative 3, we shade a closed circle on negative 3 because negative 3 is included because of the equal to. And we shade to the left because x is less than or equal to. Now here you'll notice that our inequalities are shaded in two opposite directions. And that's okay because we have an OR statement. So x could either be a solution here or here because it could be one or the other. So our solution is x is greater than 7 or x is less than negative 3 because it's going to be less than or equal to, negative 3. Let's try another example. So negative 7x plus 1 is greater than or equal to 22, or negative 10x plus 41 is greater than or equal to 81. So here we'll do the same thing. We're going to isolate x. So I'll subtract first by 1 on both sides. I have negative 7x. This cancels out because they're opposite. Is greater than or equal to 21. And we could divide both sides by -7 to get the x by itself. And remember that when we multiply or divide by a negative, our inequality sign flips. And 21 divided by -7 is -3. So x is less than or equal to -3. And let's do the same thing on this side. Subtract 41 on both sides. This cancels out because they're opposites. -10x is greater than or equal to 40. So here, we'll divide both sides by -10. And because we're dividing again by a negative, our inequality does change. So x is less than or equal to -4. So before we do anything, I recommend that we look at our inequalities on a number line. So we don't need to plot that many numbers now. So -4, -3, -2, -1, 0, 1. I didn't even have to plot all of those, but you could if you want to. And for this one here, x is less than or equal to -3. We shade in our circle because it is equal to -3 and it's also less than -3. So I shade to the left. For our next inequality, x is less than or equal to -4. Make sure that you shade in because -4 is included. And since x is less than, we're also shading to the left. Now, if you notice on this number line, our two inequalities overlap. And remember that our x is going to be either one of these. So it's either going to be x is less than or equal to -3 or x is less than or equal to -4, meaning that our answer could be anywhere here. It could either be here, it could be here, it could be on -4, it could be over here. So in order not to be redundant, we could just say that x is less than or equal to -3 because this includes x is less than, it includes x is less than or equal to -4 because anything to the left of -3 is going to include anything to the left of -4. So this is our final answer. We don't need to say one or the other because no matter what, our solution is going to be included within this inequality. Here we have another example. -4x plus 60 is less than 72, or 14x plus 11 is less than -31. So we're going to do the same thing, isolate our x. Opposites cancel out. I'm left with -4x is less than 12. So for this one here, remember that when we divide by a negative, our inequality flips. So this cancels out and we're left with x is greater than -3. And let's isolate our x on this side as well. -11, -11, these cancel out. 14x is less than -42. And here I'm going to divide by 14 on both sides. And because I'm dividing by a positive, our sign stays the same. So x is less than -3 because -42 divided by 14 is -3. So here we have our two inequalities, and let's see what it looks like on a number line. So here we're not dealing with that many numbers, we're just dealing with -3 really. So on our number line, I'm going to plot -3, -4, -2. And I don't need to plot any more than that. So x is greater than -3. I put an open circle on the 3. And since it's greater, I'm going to shade to the right. So it shades in this direction to the right. And now if I look at my other inequality, where x is less than -3, it's again an open circle on -3, and because it's less than, I'll shade to the left. Now, by looking at our inequality and our number line, it looks like almost all real numbers are included. However, notice that none of these inequalities include -3, so it's not all real numbers. So we do have to write x is greater than -3 or x is less than -3. If one of these inequalities was less than or equal to or greater than or equal to, and this was shaded in, our solution would be all real numbers. Here we have another example. -15x plus 4 is less than or equal to 109, or -6x plus 70 is greater than -2. So again, isolate our x, subtract 4 on both sides. This cancels out. -15x is less than or equal to 105. And in order to get rid of the -15, we have to divide both sides by -15. -15 divided by -15, that cancels out. Since we're dividing by a negative, our sign does flip. And 105 divided by -15 is -7. And we're going to isolate the x on this inequality as well. So we subtract 70 on both sides. -6x is greater than -72. And we have to divide by -6 on both sides. Remember that when we divide or multiply by a negative, our sign flips. This cancels out. X is less than 12 because -72 divided by -6 is +12. And again, let's plot our number line and see what we get. So here, okay, so here we have -7 and +12. So I'm going to start with -7 here, -6. Actually, I'm just going to put -7 and 12 on opposite ends. So -7 would be somewhere here, 0 would be somewhere in the middle, and then 12 would be to this far right. So for our first inequality, where x is greater than -7, greater than or equal to, we shade in our circle because -7 is included, and then we shade to the right. So I'm going to try to do that as straight as possible. Oops. And then x is less than 12. We have an open circle because 12 is not included, and we shade to the left. Now our answer is going to be one or the other. And if you notice, they overlap completely. Even though our 12 is not shaded, when we did graph x is greater than or equal to -7, it does shade in this direction, so it actually does include the 12. So because our inequalities overlap like this, our answer is all real numbers. And what that means is that x can be any number for our compound inequality to be true. Even if it's 12, 12 is greater than or equal to -7, making this one true. Because it only has to make one of them true since we're using or. So it's either going to be true for this one or true for this one, or sometimes even true for both when it does overlap.